Assalamualaikum. My name is Dr. Muhammad Qureshi, and today we're going to talk about the compliance of the lungs. So, if one has to answer a general understanding of the meaning of the compliance, you must know that someone who is agreeing to is basically a compliant person. So, as a doctor, when we prescribe somebody the medicine for, let's say, hypertension, and it goes back, and after some days he has come back and he has not taken the medicine as we have prescribed, we would say that the person is not compliant. We also use the word non-adherent to certain patients, but you get the idea of a compliance is someone who's complying with the orders that you have given to it. Now we're talking about the mechanics of lungs, and here the concept of compliance is given to the organ, the lungs. So what can be a compliant lung and what cannot be a compliant lung? And when we talk about the compliance, we're talking about a property, right? So a property of a lung. So basically a compliance is the change in the volume with applied change in pressure. So when you put certain pressure, what change in the volume comes, that is known as the compliance of a certain object. For example, if you have a school bag and it has the capacity of containing 4 or 5 books in it, but then you decide to put a little bit more and you enter the 6th book or the 7th book or the 8th book, excuse me, that bag now, if it has a fabric that has made it, so there can be only 3 things that is possible. Number one, the fabric is stiff. If it is stiff, it won't allow you to put even a single book in it because it is stiff. Or if we take the thing stiffness as a property, then we were able to say that the bag is stiff or it is not that much stiff. So if it is not that much stiff, then it is compliant. Why? What is compliant? Compliant is someone is a sort of a bag in which you can put the 6th book, 7th book, 8th book, 9th book, 10th book, and it is allowing you to expand itself. Now that is compliant. But what if it is having too much recoil back? It is recoiling back like a balloon. If you put some air into a balloon, it goes into the balloon, but it has a recoil. It will come back. It has the elasticity. The property of the elasticity is to recoil, to put everything that has been put in out, is called elasticity, and that is known as the elastance. Now we need to know about the capacitance, the compliance of the lung, and that's the basics of the lung physiology, that how much can volume it take with the pressure induced. And if you know about the ventilator settings, you would know that there are only 2 major things that you need to know about this: the volume based and the pressure based ventilation. So it has an impact into practicality as well. So a compliance of the lungs is, as we know, is the distensibility, is the property of the distensibility of the lung itself. It says that it is inversely related to elasticity, because an elastic lung will not be that much coil, that will come back. So this is inversely proportional to the elastance of that particular object that we're talking about. In case of lungs, it is lungs. So when a lung is more elastic, it is less compliant, and when the lung is more compliant, it is less elastic. So these are the 2 things that you need to know. And also the stiffness, because of when a lung is stiff, it won't have the ability to distend, right? So then it is also less compliant. So it says that describes the distensibility of the lung and the chest wall is inversely related to elastance, which depends upon the amount of the elastic tissue, but natural. Is inversely related to stiffness, it is not stiff. The slope of the pressure volume curve. So if you graph if you have a graph between the volume and the pressure, you put the pressure on the x ordinance and you put the volume over the y ordinance, and then you graph this curve in between. So you come to know when you increase the pressure, the volume will increase. So if you are increasing a little bit pressure, for example, if I have this one, right? Our pressure, say unit 1, then the volume will go up here. And if you have the pressure volume 2, the pressure will go up here. So the graph will be like this, very steep, right? But what if I put the pressure like at the value 10, but the volume is a little bit high, and then at the 20 the volume is a little bit more high, then the graph value would be like this, because we have to match these dots, right? It would be very less steeper. So the slope, so when you have this pressure volume curve, when you graph it, you plot it between the pressure and the volume, knowing the distensibility. So you know the compliance is basically the slope, that how steep it is. If it is more steeper, it is very compliant object. You put something in it and it is expanding, 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 expanding. And if it is very steep, it is not so steep, so it is not very compliant. So it needs a lot of pressure to increase that volume, is a less compliant. So a property of the lung, that it is compliant. So it is also known that compliance is also known as the slope of the pressure volume curve. The change in the volume for a given change in pressure refers to transmural or transpulmonary pressure. So when we're talking about the pressures, any change in this pressure that we're talking about the pressure volume, these are the pressures which are applicable in different parts of the pleural of the chest cavities, right? That's it for now.